Mention mobile gaming in a room full of PC and console purists, and you're usually met with an immediate eye roll. The community generally views phones as casual microtransaction traps, defined by clumsy thumb controls and hardware that heats up within minutes of a match starting. Yet that perspective ignores the raw computational reality in your pocket. A modern smartphone processes data at speeds that dwarf the Nintendo 64 that pioneered the 3D era. These devices even possess more raw power than mid-2000s dedicated rigs like the PlayStation 2. We are now running massive, open-world multiplayer titles on portable glass slabs. Modern mobile hardware contains the engineering necessary to compete with legacy home consoles. However, that potential often remains dormant because users approach the device with a casual mindset, neglecting the specific configuration and cooling required for sustained performance. Traditional controllers force your hands into a fixed grip, with analog sticks and buttons locked permanently into a single manufacturer-defined layout. A touchscreen functions as an infinite controller, allowing you to move, resize, and reorganize every button to match your specific hand anatomy and reaction speed. While casual players rely on a simple two-thumb setup, competitive mobile professionals spread their inputs across the screen, utilizing a four-finger claw layout that allows for simultaneous movement, aiming, and firing. The most significant advantage, however, is a sensor already inside the device, the gyroscope. Instead of dragging a thumb to aim, the gyroscope detects the physical movement of the phone itself. By physically tilting the device, players can counteract weapon recoil with micro-adjustments, tracking targets with the speed and precision of a PC mouse. Combining custom button placements with optical-style tracking creates a hybrid control system that offers more flexibility and precision than a standard gamepad. Even with a professional control setup, pushing these internal components to their limit creates an immediate physical problem: heat. Mobile GPUs generate thermal energy far faster than a phone's passive cooling can dissipate it. This leads to the hardware bottleneck known as thermal throttling. This chart maps internal temperature against frames per second. As the heat hits a critical ceiling, the device protects itself by slashing processing power, which results in the stuttering and FPS drops that ruin your rank. Internal vapor chambers and graphite pads are designed for short bursts of activity, but they quickly reach a saturation point during a 20-minute match. Severe frame drops rarely indicate a weak processor. They are the physical signature of heat soak. Effective thermal management serves as the bridge between theoretical hardware specs and actual, sustained frame rates. Resolving this heat saturation requires moving beyond passive materials and into thermoelectric cooling, specifically the Peltier effect. An active semiconductor cooler pumps thermal energy away from the phone's chassis using electricity, pulling heat through a specialized plate and exhausting it via a high RPM fan. This forced heat removal stabilizes your frame rate, allowing the GPU to run at peak clock speeds indefinitely. The 2026 hardware market offers a range of professional solutions, from 35-watt magnetic units capable of sub-zero temperatures to liquid-cooled systems that utilize a separate desktop pump to isolate heat from your hands. An active radiator is a baseline requirement for anyone attempting to maintain peak frame rates and protect internal battery health during high-load gaming sessions. Simply owning a cooler is only the first step. You must understand thermal transfer to optimize the rig. You must remove the phone case entirely. Materials like TPU and leather act as insulators that trap heat and prevent the cooler's thermal plate from making direct contact with the phone's chassis. This heat map shows that thermal energy is not distributed evenly. The core heat source is located near the camera module, where the processor sits. Positioning the cooler dead center over the battery ignores the primary thermal bottleneck. You also have to monitor the dew point. In humid environments, a high-wattage cooler can drop the temperature so low that internal condensation forms, creating a moisture risk for your internal circuitry. A smartphone stripped of its case and equipped with a stabilized Peltier cooler, custom layout, and high-precision gyroscope tracking stands as a legitimate professional-grade portable rig. Let us know how you've optimized your device. Are you running a custom four-finger UI, or do you have a specific cooling rig you swear by? Drop your setup in the comments, hit subscribe, and we'll see you in the next one.